I'm going to be discussing a type of ciphers that I've learned in the AoPs Academy Algebra 1 prep class yesterday. And this type of cipher is called a Bacon cipher. And while it may sound yummy to you, it actually is quite complicated. It involves using binary to encode and decode messages. Now you might be thinking this would be relatively easy to decode, because if you just wrote a bunch of ones and zeros on a piece of paper in code, then anyone with the right tools could just decode it. But it's a little bit harder than that. So, you write a message in normal form, and it could be like a jumbled up message with a bunch of random characters, but the colors or the size of the letters are different, and there will always be two types of colors or two types of letter sizes in a Bacon cipher message, so that when you decode it, you could have a binary message. Let's write down a sample message here in two different colors. So I'm just going to write down a bunch of gibberish text here, but that's not the whole point. And then you can have two different colors. And then more colors. But you can only have two in one of these ciphers. Okay. Alright, so we have a variety of different colors in this list. So, usually in a Bacon cipher, they tell you which color represents ones and which color represents zeros. So in this case, it's just a sample message. The red would represent the 1, let's assume, and the blue would represent the 0. So we can now translate this message into a binary message. Now you might note that these letters here mean nothing at all. They're just there to mask the true meaning of the message. All that really matters is the colors in this case. So we can write this out as a binary message here. So it would be 1, 1, 1, 1, because these are all reds, and then it will be 0, 0, 0, 0, and then 1, 1, 1, 1, 1, 1, and then 0, 0, 0. Of course, it's a very long binary message, but in binary, messages are usually long. For example, the word "the" is a very long binary message. So once you get this, you could easily go in and decode this. Now, in order to do that, you would have to, in the class, we had a sheet of binary numbers for reference. Like, for example, we wrote down 0, 1, 2, 3, 4, 5. Those are the decimal numbers, and then we converted that to binary. So using that, you could then convert this. Now, an easy trick to converting this is you group them in 5. So you have 5 here, 2, 3, 4, 5. And then you have 5 here. Now, the spacing is going to be all weird here. That's always going to be the case with these binary messages. That's also part of the code. Once you decode it, your message will sound a little bit weird. That means you have to put some extra spacing in there. Okay, 1, 2, 3, 4, 5, and then the last two over there are alone. Okay, so with your code, you could then go in and decode this. And an easy trick to doing this, again, is divide each of these numbers by 2. Like, you could divide 11,110 by 2, and then your remainder will spell out the binary number. Your remainder will be like 1, 1, 1, 1, 1, 0, or whatever it is. And that's how you know what number to divide. So that's how you encode and decode messages in the Bacon cipher. It actually doesn't seem like a very secure cipher, but when you get into it, it's probably more secure than any cipher you've looked at before, like seizure ciphers or anything like that.